All right, here are the solutions for Course 3, Class 1, Homework number 2. Number 1 says, for problems 1 and 2, use the figure below. Here we see angle FAD equals 90 degrees and angle FDE equals 45 degrees, and segment FA is 10 inches long. All of that is given. What is the area to the nearest square inch of triangle FAD? Well, in order to find the area, we have to find 1/2 the base times the height. Because this is a 45, 45, 90 triangle, then these two angles are congruent, and because these two angles are congruent, then their sides must also be congruent. So if this is 10 inches, then this is 10 inches, so we can use the equation 1/2 the base times the height, and the base is 10 and the height is 10, so 1/2 times 10 times 10, that's 100 divided by 2 is 50. So the area to the nearest square inch of triangle FAD is 50. The answer is A. For question 2, using the same triangle, it's asking what is the perimeter to the nearest inch of the triangle FAD. So remember, the perimeter is just the measure of all three of the sides added up. We know this side is 10 inches. We also know because they're congruent, then of course this side must also be 10 inches. What we're trying to figure out is what is this side over here. We can use a squared plus b squared equals c squared to solve for this. We know side A and side B are both 10 inches, so that's 10 squared plus 10 squared equals c squared. Well, 10 squared is 100 plus 100 equals c squared. 200 equals c squared, or c equals the square root of 200. Using your calculator, you would find that c equals about 14.1. So if you add 14.1, which is the measure of this side here, if you add that to the measure of this side of 10 and this side of 10, you get 34.1 roughly, or H, 34. Questions 3 and 4 use the same figure as well. In this case, we are told that line AB is parallel to line EC. So AB is parallel to EC, and AE is parallel to BC. So AE is parallel to BC. And line BD is perpendicular to line EC, which we don't need to mark that because we see this 90 degrees here, so we know that is the case. And line segment ED is 11 feet long, which is given on the figure, and segment BC is 10 feet long. BC here is 10 feet long, and segment BD is 8 feet long. Angle AEC is approximately 127 degrees. To the nearest square foot, what is the area of the parallelogram ABCE, this parallelogram right here? Well, if you look, you can think about this as a rectangle with a triangle on either side. If you think about it that way, then the area inside this little imaginary rectangle is 88 feet, 88 square feet, because you've got a side of 8 feet and 11 feet. So that takes care of the square. Now you got to find the two triangles. They're going to have the same area, just one over here and one over here, so you really just need to find one of them and then double it. Well, if you look here, they give you the measure of the segment here 8 and the segment here of 10. If you think about it very carefully, sometimes you're going to see that they're giving you a free 3, 4, 5 right triangle, because if you reduce these by 2, this becomes a 4, and this becomes a 5. And so if this were a 3, 3, 4, 5, if you divide all these by 2. But since you didn't divide them by 2, this is 8, this is 10, so this side right here is going to be 6. And because it's going to be 6, then 1/2 the base, 1/2 the base of 6 times the height of 8 is going to give you 48 divided by 2, or 24 for each triangle. So the area of this triangle is 24. The area of this triangle is 24. It's 48. So total is going to be 88 plus the 48 for the two triangles. It's going to give us 136. Correct answer is D, 136. Question 4 asks, using the same graphic, to the nearest degree, what is the measure of angle CBD? Measure of angle CBD. So they want us to find this angle right here. Let's just walk around what we already know. This is 127 degrees here, and these are parallel lines intersected by this line, which means up here this is also going to be 127 degrees, which means what's left over here for this angle on this side is 180 minus 127, or 53 degrees. If this is 53 degrees, that means this is 53 degrees. We know that this angle here is 90 degrees. So altogether, these have to equal 180. So if we take 90 plus 53, you get 143. 180 minus 143. That makes the measure of this angle right here 37 degrees, which makes the measure of the other angle 37 degrees. So the correct answer is G. And question 5 says the figure below is a regular pentagon, which means you've got 5 equal sides with all the angles on the inside also equal. What it's asking, though, is what is the sum of the angles 1, 2, 3, 4, and 5? Those are the angles outside the pentagon. So in order to know that, all you need to do is figure out this measure of angle inside. Then you'll know what's left from 180 on the outside. Multiply that by 5, and you'll get the answer. So we use the formula 180 times n minus 2 divided by n equals the measure of the angles on the inside. In this case, there are 5 sides, so 5 minus 2 is 3. So 180 times 3 divided by 5 equals 540 divided by 5, and simplify that to 108. Now remember, that's all you've done is find the measure of the inside angles to be 108. So you want to find the measure of the outside angles. It's going to be 180 degrees, which is the measure of this whole line here. And then take away the 108 that you just found, and that leaves you with 72 degrees as the measure of one of these angles. Multiply that by the 5 angles it's asking you about, and you get 360 degrees. The correct answer is C. Question 6 says the legs of a right triangle have lengths of 3 feet and 4 feet respectively. So we've got 3 feet and 4 feet, and that means our hypotenuse is going to end up being 5 feet because this is a perfect 3, 4, 5 triangle. The legs of a similar right triangle have legs of 12 feet and 16 feet respectively. What is the length of feet? What is the length in feet of hypotenuse of the larger triangle? What is this measure right here? Well, if the 3 went to 12, that means it got multiplied by 4. The 4 went to 16, it got multiplied by 4. So the 5 multiplied by 4 gives you 20. The correct answer is J. Okay, this last question in the homework problem could give you a little bit of trouble. It takes several steps to get it right, but think about it this way. It's a story problem that just takes a lot of work. It says the area of a rectangle is 119 square inches. The rectangle's length is 3 feet less than twice its width. So I'm going to draw something that looks like this. I'm going to say its width is W and its length is 3 feet less than twice its width. So that would be 2W minus 3. The overall area is 119 square inches. So I know that if I multiply W by 2W minus 3, I would get, so W times 2W minus 3 would have to equal 119 square inches. If I use the distributive property, I will get 2W squared minus 3W equals 119. Now, it's starting to look like a polynomial, so I'm going to subtract 119 from both sides. And I'm going to get a new 2W squared minus 3W minus 119 equals 0. Now, at this point, I'm going to try to factor that. I like to use that FOIL method. So I know I'm going to go like this. I'm going to have a 2W here and a W here. I've got to look for two numbers when multiplied together give me 119, but when added together give me a negative 3. I'm going to cheat a little bit and think about the fact that 2, 3, 4, 5, 6 do not go into 119 equally. The number 7 does. I'm just taking a guess. I whip out my calculator and I actually find that 119 divided by 7 is 17. So 7 times 17 equals 119. So if I were to put the 7 here and make that positive, and put the 17 here and make that negative, using the FOIL method I could check, and I would see I would get 2W squared plus 14W minus 17W, and then minus 119. So that would exactly be what I was looking for. And also, now I know that those things are going to be equal to 0. Well, if I set these up equal to 0, 2W minus 17 equals 0, or possibly W plus 7 equals 0. Remember, though, we're trying to find a measurement. We're trying to find a length up here. We're trying to find out what W is. Well, in this case, W would equal negative 7. It's impossible for a side of something to be a negative length. So that's gone. That's out. And now we're left with 2W minus 17 equals 0. We solve for that. 2W minus 17 equals 0, or 2W equals 17. Dividing both sides by 2, we get W equals 8.5. Once we know that W equals 8.5, again, the question they were asking is what is the perimeter in inches? So W equals 8.5, and then the length must equal 2 times W, or 17 minus 3. That would equal 14, which means this side is 14 and this side is 8.5. You add those up, you get 17 for the two widths and 28 for the two lengths, 14 plus 14, and overall it is 45. Correct answer is C. And you could also check your work by multiplying 8.5 times 14, and you'll see that indeed that does give you the 119 square inches you were looking for. Obviously, this is a very challenging problem, one of the last ones you'll see on the ACT test, but if you've been banking up some of your time, you'll be able to spend 2 or 3 minutes solving this problem. Phew, good job. That was a tough one, but now you have finished homework 3.1.2. You are nearly finished with the course.